In this video, I'm going to be explaining how angle relationships can help us prove that two lines are parallel. If you know what angle types are created when two parallel lines are cut by a transversal, then we can talk about the relationships of those angle types to prove that the lines are actually parallel. To start off with, let's talk about which angles are congruent. Corresponding angles have to be congruent if two lines are parallel. Also, alternate interior angles and alternate exterior angles must also be congruent if two lines are parallel. So let's use that to answer some example questions here. If the measurement of angle 3 is 62 degrees, then what is the measurement of angle 7? We'll establish their type of angles. They are corresponding angles. So corresponding angles must be congruent in order for these two lines to be parallel. So if angle 3 is 62 degrees, angle 7 must also be 62 degrees because corresponding angles are congruent. So figure out what type they are, think about what relationship must be true, and then you can answer these questions. Let's do one with a little bit more algebra. If the measurement of angle 5 is 2 times the number, and the measurement of angle 4 is 3 times the number minus 60, then find the measurement of angle 5. So let's establish what type of angles angle 4 and angle 5 are first. They are alternate interior angles, so they must be congruent or equal. So we can set these two expressions equal to each other. Angle 5 is equal to angle 4, so 2x must be equal to 3x minus 60. Then we can solve for x. Subtract 3x from both sides. We get negative x equals negative 60. And then we can make everything the opposite, or we can multiply or divide by negative 1 and get x is 60. If x is 60, the measurement of angle 5 was 2 times x. So 2 times 60 must make the measurement of angle 5 120 degrees. So corresponding angles are congruent. Alternate interior and alternate exterior angles are congruent. There's two more relationships that must be true in order to make two lines parallel. Same side angles must have a supplementary relationship. So if you remember same side supplementary, that alliteration may help you remember the relationship. If you can remember that same side angles are supplementary and the other angles are congruent, that's a little bit easier to remember. So same side interior and same side exterior angles must be supplementary or add up to 180. So if the measurement of angle 4 is 142 degrees, then what is the measurement of angle 6? Well, angle 4 and angle 6 are same side interior angles, so they must be supplementary or add up to 180. So angle 4 plus angle 6 must add up to 180. Substitute the values that we got. Angle 4 we were told was 142, so 142 plus angle 6 must be 180. Subtract 142 from both sides, and you get the measurement of angle 6 is 38 degrees. You can then check it, make sure it adds up to 180. Let's do another example with more algebra. If the measurement of angle 2 is 48 degrees, and the measurement of angle 8 is a number plus 68, then find the measurement of angle 8. Let's figure out what type of angles angle 2 and 8 are. Angles 2 and 8 are same side exterior angles, so they must be supplementary. They must add up to 180. So angle 2 plus angle 8 is 180. Substitute some values that we were given. Angle 2 is 48. Angle 8 was x plus 68. We can combine some like terms and solve for x. 48 and 68 give us 116. And if we subtract 116 from both sides, we solve for x and we get 64. So if x is 64, then the measurement of angle 8 is whatever x was plus 68. Substitute the value of x. So 64 plus 68 is 132 degrees. We could then double check, make sure that angle 2 and then angle 8 add up to 180. And they do. So same side angles are supplementary, whether they're same side interior or same side exterior. Let's talk about one more relationship here. Let's define perpendicular lines. Perpendicular lines are two lines that intersect at exactly 90 degrees or intersect at exactly a right angle. There's a special symbol that means perpendicular. It looks like an upside down T. It's actually creating two right angles there. And it's an example of two perpendicular lines, so hopefully that helps you remember the symbol. And we read it perpendicular to. So let's look at an example here where we have two lines being intersected by a transversal, all intersected at 90-degree angles. So because line B and line C are parallel and they're being intersected by a transversal, that transversal is creating 90-degree angles, so therefore line A must be perpendicular to line B. And because B and C are parallel, it must also be perpendicular to line C. So if two lines are being intersected in a perpendicular fashion, the intersection of another line that is parallel must also be intersected in a perpendicular fashion. We can use that relationship to help us solve some examples. So in this example, we're told that line L is parallel to line M, and also line N is perpendicular to line L. If the measurement of angle 5 is 3 times the number, let's solve for that x value. Well, if we know that line L and line M are parallel, and line N is perpendicular to line L, line N must also be perpendicular to line M, because L and M are parallel, and N is perpendicular. So the measurement of all of these angles must be 90 degrees, including angle 5. So if angle 5 equals 90, then that must mean that its expression 3x equals 90. And we could divide both sides by 3 and solve for x and get x is 30. So perpendicular lines intersect at 90 degrees. And if two lines are perpendicular and we draw a second line that is parallel, it must also be perpendicular. And that creates a bunch of 90-degree angles, which can help us solve for an algebraic expression if we need to. So there's all your angle relationships to help you prove that lines are parallel. Corresponding angles, alternate interior and alternate exterior angles are congruent. And same side angles, same side interior and same side exterior are supplementary.